So uh, so the in Jetpack Compose UI, uh, like, have you wondered, like, when you changed uh, the text, when you change the text or any states gets updated, and then then the compose only updates that composable uh, that are reading those states, and skip all the other compose and skip all the other composables. How does it maintain, or how does it identify which composables are reading which states, and when the state gets changed, how does it know, like, which composables to re-execute or recompose? For this, Jetpack Compose maintain a structure to store all this information. We call this slot table. Slot table store all the composition states, all the composable functions, call its parameters, and its result. Function call its parameters and result. So slot table is basically a linear data structure to hold all this information. Linear data structure to hold this information. So let's take an example to see what how the compose runtime creates this slot table and updates the slot table when the state gets changed. So suppose in this counter screen we saw some header and the counter and the footer. So simply let's uh, so simply the header function simply display a text, type header, and the footer simply show text footer. And this counter accept a mutable state counter, and it reads that states, and it also updates states when the button get clicked. So the compose runtime creates this slot table when this compose gets executed for the first time. So and it store all this information inside the slot table. So when this composable gets executed the first time, uh, it stores the group. It stores uh, all the composable body, the start and end. We call it a group. So basically it starts uh, during the compilation. The compiler add an extra parameter called composer, and it tracks the composable body with start and end. So composer dot start, and it assign a unique ID. So it inserts a group for the counter, and then for insert a group for then it will also insert a group for remember. So remember is also a function call. Remember, and it also slot to store its value, and then it store a group for header, and then let's call body mode. So it insert a group body, and the body also contains some other states like the button group and the on click lambda. So it on click lambda for text, it all store this. Okay. So when the button gets clicked, so during the first time when this composable gets executed, it's created a restartable group for that body. So this one is the restartable group, and it also maintains some other info like the snapshot system. Snapshot system like which composables reading which states. So the counter state is reading by body. So it creates like a map table like which mutable state is reading by which composable. So when the button gets clicked, the mutable state informs inform snapshot system that I got changed. It will look that this state is reading by which composable. So it will check that this body composable is reading. So it will ask the composer to update its state. The composer runtime will look the slot table, and it will look for that body here and check its previous value and new value, and then update it. This recompose scope. This recompose scope also add an anchor for this body, so it will directly ask the Jetpack Compose runtime, I want to update this anchor. This anchor is basically it is like an index, so it will look directly at this index and update the body. We will look more in later. We will look in more detail what is uh, snapshot system, restartable group, snapshot system, restartable group, recompose scope, all those things. These groups also hold some other metadata like the size, how many children it has, 1, 2, 3, like 1, 2, 3, 4, like 1, 2, 3, 4, 5, 6, 7. So it's stored like 7. I have 7 children. Like remember, also hold like how many children it has. It has 2 children. So and the header, how many children it has. So it is like the 1 children. So when we want to replace some group, like I want to replace this counter group, so it will shift all these 7 children and move this gap upwards. So all this will shift down and the gap will move upward. So when the structure of a tree gets changed, then only this happens. So that is very rare in Jetpack Compose UI. The UI gets changed. The UI gets updates by changing, but it is very rare that the compose structure has changed. It has only the compose UI will change only by the UI states. Not it is very rare. So and the moment this gap and this group is linear, so it takes big O of n time. So in the worst case, the complexity is big O of n, and other operations like updates, insert, delete, all these are constant time operation. So these are all about the slot table. Okay, thank you.